This video is about random variables. By the end of this video, you should be able to create a probability model for a discrete random variable. You should be able to find the expected value and standard deviation for a probability model. And you should be able to find the expected value and standard deviation of the sum or difference of two independent random variables. First, random variables. Random variables are variables whose value is based on the outcome of a random event. And I'll give you an example in a second. Random variables can be discrete, where the outcomes can be a few separate values, like rolling a dice, you get 1, 2, 3, 4, 5, or 6. Separate values. You can't roll a dice and get 1.5 or pi. Okay? Random variables can also be continuous, where the outcomes can be within a range of values. For example, the amount of time it takes to complete a survey, or someone's height could be thought of as a continuous variable because it could be any value within a range of values. Okay? For most of this chapter, we will focus on discrete random variables, but these ideas also can be applied to continuous random variables. So first, a probability model. A probability model is a collection of all possible values or outcomes and the probabilities that they occur. So here is a probability model for rolling a dice. This is a very simple example, but I think it illustrates the point. Okay, the possible outcomes, 1, 2, 3, 4, 5, or 6, and the probability of each outcome. So here's another example. An insurance company offers a death and disability policy that pays $10,000 when you die, or $5,000 if you are permanently disabled. It charges a premium of only $50 per year for this benefit. Is the company likely to make a profit selling this plan? Okay. At first thought, you may think only $50, a year, and if something, if I die or get disabled, a lot of money comes back to me. But let's see if this company would make a profit with this policy. Okay. Based on past data, the company estimates the probability that an individual dies is 1 in 1,000. Okay, that's not a true number. They just made that up for the textbook. But let's just assume it's 1 in 1,000. And the probability that a person becomes permanently disabled is 2 in 1,000. The probability model would look like this. Okay, and the truth is, insurance companies actually have very complicated and very good formulas to take all kinds of factors into effect to estimate the probability that you would die or become disabled or something else would happen. If a fire would, your house would catch on fire, or you get in a car accident. They have all kinds of models that kind of estimate the probability that different events occur. That's how they run their business for insurance companies. Okay, let's just take this simple example and look at this a little more in depth. Okay, let's look at the expected value, which is a huge concept, a very important concept in this class. Okay, to calculate the profit for the company, let's assume for 1,000 people that what we thought would happen, that one person dies and 2 people become disabled. Okay, the insurance company would have to pay out $10,000 for the person who died and $5,000 to each person who becomes permanently disabled. Okay, and that comes up to, in the year, $20,000 of payout, which equates to $20 per policy. Okay, so they would expect to pay out $20 per policy, which means they'd make a profit of $30 to pay their employees and their building costs and those other things. Okay, their profit would be $30 per policy. Now, the expected value, or the mean, this is the center of this distribution. The mean would be the expected value. That's what this symbol is right here. Or we would take each value and multiply by the probability of that value. Okay, and add the value times the probability that that value would occur, and this times this, and add those together. Okay, that's how we find the expected value. Okay, now in general, here is the formula, which uses again this summation sign to add up, all the outcome values times the probability that that value would occur. Okay, that's how you find the expected value. Now for the standard deviation, we again have the payout values and the probability that that value would occur, and we also have the deviations. Okay, this is just like we saw back in chapter 6 when we defined standard deviation. We look at the deviations from the means, and those are these values right here. Okay, and just as we saw in chapter 6, we will look at the squared deviations. So that makes everything positive. Okay, now instead of adding these up and dividing by n minus 1, we're going to multiply each of these squared deviations by the probability that that outcome value occurs. Okay, and we add all those up and we get the variance for this probability model. Okay, also, the standard deviation is the square root of the variance, and so that gives us the standard deviation for this probability model. Okay, and down here in general, the variance, which is the standard deviation squared, is equal to the sum of the deviation squared times the probability that that value would occur. Okay. The next topic is about adding and subtracting random variables. In chapter 6, we discussed that when we shift the data, meaning we add or subtract a constant to each value, that would shift our measures of position, but the measures of spread would not change. Also, if we rescale the data, meaning we multiply or divide by a constant, that would rescale the measures of position and the measures of spread. A similar thing happens with the expected value, which is a measure of position, and the variance or standard deviation, which are measures of spread. Okay, there's some boxes down here. Nothing here should be really new to you. It follows the same rules we talked about back in chapter 6. Okay, the point of this chapter is what happens when we add or subtract two random variables, not a constant, another random variable. Okay, let's go back to the insurance company, and we know that the insurance company will insure more than one person. Okay, so let's think about two people with an expected payout of $20 per policy or per person. We would expect to pay 20 plus 20 or $40 for insuring them both, or paying out $40 if we're insuring both of them. Okay, so the expected value of x plus y is equal to the expected value of x plus the expected value of y, or in general, the sum or the difference would follow this formula. Okay, that kind of follows our intuition that if we, insure 2 or 3 people, we'd expect the payout to be the same as the sum for all of them. The variability on two policies, however, may not follow your intuition. Okay? If the random variables are independent, then there is a simple addition rule for variances. Okay? Variances add, which is a very nice property for us to use, that variances add. Okay? So we could find that the variance for these two policies or these two people would be this amount, which, by the way, is different than insuring one person and doubling the payout. Okay, that would be this down here, which would be about twice as much as insuring, 2 people. Okay, so that means that because the company can spread out the risk, the standard deviation for the company's payouts would be lower. Okay, now in general, the variance of x plus or minus y is equal to the variance of x plus the variance of y. Notice that this has a add or subtract right here, but this is only add. Okay, so if you look, we're looking at the difference between two random variables. The variance would only be those two variances added together. It would not be subtracted. Okay. Now, because the standard deviation of x is equal to the square root of the variance of x, we can use that property to derive what I call the Pythagorean theorem of statistics. So the standard deviation of x plus or minus y is equal to the variance of x plus the variance of y. Okay, also notice again that there's no subtraction here, it's just add. Okay, and the standard deviation of x plus or minus y is the square root of the standard deviation of x squared plus the standard deviation of y squared, which looks kind of like the Pythagorean theorem. So I call it the Pythagorean theorem of statistics. Okay, whenever you're working with two or more random variables and you're looking for the standard deviation of those variables, you have to use the Pythagorean theorem of statistics. Now, the formulas and the concepts that we have discussed in this chapter will apply if there are 10 possible outcomes or 100 possible outcomes or 10,000 possible outcomes or infinitely many possible outcomes. Okay, which means that these concepts and these formulas also can be used for continuous random variables. Okay, when two independent continuous random variables have normal models, so does their sum or difference. That a lot of these concepts that we've discussed in this video are still true for continuous random variables. So this video was about random variables, about probability models, and the expected value and standard deviations for probability models. Thank you so much for watching.